My name is Elizabeth Grimes, and I, along with Jacqueline Olson and Sean Taylor, conducted our project on the effect of caffeinated beverages on undergraduate students. One of the fabled stereotypes of a college education, the working world, and in life is that caffeinated beverages can make you perform better, at least for a short period of time. We decided to put this to the test. So our problem statement is: does drinking caffeinated beverages affect student performance on tests? Our population and population sample consists of undergraduate students between the ages of 17 and 21, particularly those who have at least considered drinking a caffeinated beverage in order to boost their academic performance. The sample technique consists of two groups, one control group and one experimental group. The control group has 15 college students who will take a test not under the influence of caffeine. The experimental group has 15 college students who will take a test under the influence of caffeine. Our beverage of choice was coffee, as that is the most fabled caffeinated beverage. The flowchart shows the experimental procedure that we created for the experiment. The respondent sits in front of a computer in an environmentally controlled room, and the researcher either says one of two dialogues in the next part of the flowchart, depending upon which group the respondent was in. And in the final part of the flowchart, the researcher will leave the testing room, the respondent will take the test, and then once the respondent has finished taking the test, they will just inform the researcher that they have finished the test. So essentially, the experimental procedure was the same, it just depends upon which group the respondent was in. The following video shows a simulation of the test for the control group on the computer. Here you can see the diagnostic questions that were asked, such as what is your grade level in college and were you provided coffee during the exam? And these were the collegiate questions that were asked of each respondent, and all of these questions were taken from a College Board exam, so they are for college-ready students. Next, we have our summary statistics and graphs. The following table shows the summary statistics of our data for both groups. Here you can see the percentages regarding the mean, median, mode, minimum and maximum values, the range, and the standard deviation. And the majority of these values will be used in our future calculations. Here is a graph of the demographics of our respondents by undergraduate grade level. We aim to have at least a fourth of each undergraduate grade level to be represented in our experiment. That way, every grade level is about equally represented in our experiment. The bar graphs now show the test percentages of those who were not provided caffeine, as well as the test scores of students who were provided caffeine. So in order to analyze this data, we had to utilize inferential statistics, and our method of choice was the inference of two means. This was the most ideal method to use since it can analyze the potential relationship between two sets of data. In this method, there were several assumptions that were utilized as well. First, each group was a sample from a distinct or separate population. The data collected from one group did not have an effect on the results of the other group, so that they are independent, and that the means of the two sets of data were equal, which became our null hypothesis. Our null hypothesis can only contain equality, so our null hypothesis was that caffeinated beverages have no effect on an average test score, And the alternate hypothesis is that the means were unequal and that not having a caffeinated beverage would result in a lower test score than if you had a caffeinated beverage while you were taking a test. And this method was to determine the test statistic value utilizing variables for each group, such as the mean test score, the standard deviation of the sample data, and the sample size. So once the test statistic was found using the test statistic value equation, the T critical value, or Z, was determined by using the T distribution critical values table. And we also calculated the confidence interval as well. And as for our results, the test statistic value was found to be 0.0177, and the T critical values were negative 2.145 and 2.145 since the test was two-tailed. And it can also be inferred that the data is in support of the null hypothesis. So, based on the fact that the test statistic value falls between the two critical values of negative 2.145 and 2.145, again, it can be inferred that the data is in support of the null hypothesis, meaning that there is enough statistical evidence to state that caffeine did not have an effect on the mean scores of the collegiate test takers. So, in conclusion, caffeine does not have a significant effect on student performance. There could be several sources of error regarding the experiment, but the main sources could be coffee preferences, time, and sensitivity to caffeine. Some people could prefer to have their beverage in a different manner. With others, it may take longer for coffee to have an effect. And furthermore, caffeine may or may not give an individual a rush of energy, and the degree of which could vary. So to conclude, students should not focus on stimulants to perform better on exams. Instead, they should focus on alternate methods of study, such as studying earlier, studying in groups, going to office hours, etc. Thank you.